In this video, I'm going to show you all how to build a Geneva Gear, just right over here, using Inventor. This is a minimum of 3 to more parts assembly in its real build application. What we're going to do in here is focus in on building. We've got the pin, which is the easy piece. We've got the star-shaped, as I'm going to call it, piece here, okay? And then the last piece is this piece of the gear. Got it? This is called a Geneva Gear. We use it in engineering a lot. So in this class, I just want to show you how to build one in CAD and then how you can animate it. That'll be the last thing. This video is we're gonna call part 1 of the whole process because it's not gonna cover everything during this time that we're together. The first thing is to recognize the units of measurement that we're using. So you can't just start here, because if we start here, it'll automatically be in inches. So in our case, we make sure we go into new. We're gonna go into metric, standard millimeters. We're gonna hit create. Once we're inside the software, we're going to follow the standard rules of putting this thing together. Now remember, I'm going to qualify this presentation with like I've qualified every one up to this point right now for this semester, which is be aware that there's more than one way to build anything. There's more than one way to build anything. So please do not assume that what I'm doing is the only way to build things. All right, please? For the first part, the only thing we're going to build is this thing, which is the back side. Got it? This is the simplest part, so that's what we're going to build at first. So we're going to start with a new sketch. I'm going to choose to do it in what plane. I go home to find the answer to that. I want it on the top plane. Why? Because that's where I think it belongs. We can argue over that later if you would like. I'm just going to move on and draw this thing. So we're going to start with the circle. Whoops, pick the plane, pick the plane. There we go. First I got to pick the plane. Sorry, too busy talking. I'm going to let go of my mouse before I click the second time, because I know all I got to do is type in the value right there. So the outside diameter is 95. Done. The beauty of doing it this way is the dimension sticks. I don't have to go and drop a new dimension or drop a dimension to constrain that object. My next little circle, that's the diameter 76. Okay, there it is. Whoops, is that the circle or what is that? The center of my rotation, so that's not correct. I just want to draw that inner circle. So that inner circle is going to be, it gives it to me as a radius instead of a diameter, so what can I do? I can type in 27 times 2. Remember that. I can do the math on the fly, because that's the radius is 27, and I'm done. There we go. There's a little curve in here with a center reference. It doesn't matter that it's off center here. See that? Who cares that it's shown off center? This center is also this center, or is it? What do you notice? See, that center through this center, see that? Is this center. So that's okay. I can use this value of a radius 27, and that radius is defined off of that center arc, which is the first one I tried to draw, the diameter 76. When I draw this guy in here, the diameter 76, what I need to keep in mind is that is going to be used for construction. So I'd like to click on it and pick it for construction, and that's it. That way it's there as reference. I'm I'm very lazy, so I'm just going to draw a circle over here. Again, I've got the 27, so that radius, and there's 27. So I'm going to type in 27 times 2. I do my math there, and there I've got my curve. Now all I got to do is trim. Watch what happens when I trim all the way back. to where it ends. See that? It does retain its dimension. See that? So it still shows it as a diameter even though it's really not a diameter, but something was lost. How do I know something was lost, guys? Is everything fully constrained? The answer is no. Something is off. Right here, something was lost. See that? Its position in the horizontal was lost. It can be moved. See that? Still is attached correctly as far as on the right axle point. See that? But it's not horizontal. How do I fix that? For those of us who want the detailed drawing of this thing to be spot on, I would add a new item as a construction line, and then I would identify this to be what? Horizontal. What happened? It went horizontal, but this object didn't go with it. But watch now. Do you see that constraint visually on the screen where you see the little X, the arrow to the other X? Do you see it right by where my crosshairs are? Very close. It's a tiny little symbol. You'll see it in the video. When you let go, boom. Now this is locked in place. Okay? Now you're going to ask me, why didn't I put the pinhole in there? What can I put in there? I can't put the pin in there unless I machine it as one part. We're not going to machine it as one part. We're going to actually, for those of you that want to build this, that's an option. We're going to actually build it. What is the shape of, what is the diameter of that? The diameter of that is this. Whoops, I'm using the wrong, there you go. The diameter of this pin is that number, 11. That's in 11 millimeters. So 25.4 millimeters equals an inch. Half of 25.4 is what? Or half of 25, when you think about it, is what? 12 and a half, roughly, in round numbers, yeah? So 11 is a little smaller than what? Half an inch, yeah? So we'll find out what modifications we'll have to make later for those of you that want to build this, because that's going to be part of this project, is actually building one of these. You'll be able to build this in the shop from this class, Inventor, because we have access to that blog laser, all right? Because I want you to see that the dimensions you put in the software package does actually matter. It's not just for fun, you know. These dimensions translate into real physical product, okay? That'll be next for this class. So for now, what we should do, because we are going to be putting a pin in there instead, a dowel, to be specific, a little dowel. My dowel collection is next door, and we'll find the right dowel for this thing. I am going to identify that that's a diameter of 11. That's it. That builds this part at this point, okay? Of course, we're going to come up with some other problems later when it comes to build, but we'll discuss them when we're at that conversation, which will not be recorded because it's got nothing to do with just the Inventor itself. Now I'm going to pull out, and there we go. We've got the shape. I'm going to go home. How thick do we want to make this thing? We are going to make it the thickness of the material we have access to. I haven't had that conversation with you, but I will say let's make it, for the sake of just getting through this conversation, we'll make it 2 millimeters thick. That's it. Just for fun. 2 millimeters, put that in your notes. It is thin material we're going to make this. We're going to make a small little Geneva Gear. That's it. That's all you put in this thing. If you start building this shape in here, if you do that in there, sorry, my arrow can't go all the way across. If you start doing that, you're in trouble, because this is a part file, not an assembly. Okay, all we drew is one part. That was it. End of conversation. We're done with this part. We hit save because we save everything. Do not delete it, please. I'm going to save it somewhere I can find it again. That's another thing. Make sure with file management you put things in the right spot. So pay attention to where you store things. Okay, in this case, I'm going to create a folder called Geneva Gear. Okay, so I'm going to throw it in there, and this is going to be the base. Okay, but you want to give everything a name, a logical name. Then I get out of this thing. Okay, the next thing I'm going to do is go to New. And instead of picking a template for a part file, I'm actually going to go for an assembly file. Now you'll notice in assemblies we have all these different choices. We're not doing a weldment design. That's for a different class. We're going to do standard. Okay, weldments are when you're welding stuff together. In our case, this isn't going to be a welded project. So I'm going to go to a standard. It's going to be metric, okay, millimeters. There's mold design, but this isn't the mold either. So that's why I went straight for standard. We're going to hit create. When you get into Inventor and it wants to create something, it does absolutely nothing. If you were in a product called SolidWorks, it would ask you to import parts. Inventor asks you nothing. It just starts like that, and you need to know to do what you want to do. First thing I recommend, as always, is to turn your planes on so you know where in space you are, because we don't want to be lost in space. That's a TV show, not for here. So they have all the same options. I wanted to click them each individual so you could see them. And then visually. Looks the same as if you're in assembly. I'm sorry, as if you're in a part file, doesn't it? Notice that? Looks the same. It's not, but it looks the same. Place and create. This is the fun part, okay? I could have started in assembly and created my base in here. I started the other way. I created a part like most people will do. I want you to place your part, which is the base, into your assembly. And you just drop it. Now notice how it wants to drop it. See? I want to drop it this way. Can I change that? Model size, origin. Can I change its position? The answer is yes. You have an option of constraints where you can constrain this object to its new environment. So I'm going to pick do I want to pick the plane of the object or the face of the object? I've taught you mostly to pick the face. So I'm going to pick the back face of the object. That's why I'm going to suggest it that way. Just like when you start a new sketch, I ask you to start it off the body. And then I'm going to pick this plane, and boop, it drops it on that plane. You have the option of how it drops it on the plane. See that? Align, flush, or mate. And what it's doing, if you look at the object carefully, when you see little shadows on it, it's moving it one way or it's moving it literally upside down. It's hard to see because this object is pretty static in appearance, right? But that's what it's doing. I can hit apply, and now this object is stuck on that plane. I can move it here and it looks like it moved away, but you notice what it's doing? Whee! See, the plane is going with it. You see that? That's literally how this product operates. This is movable. Hear that noise? On the surface. I cannot lift it off that surface. I tapped on it for the purpose of just telling you I'm on a surface. That's my mouse. If I want to lift it off the ground so I can do this kind of noise, because I have to pick my mouse up and put it down, I can't. I have to unconstrain it. I have to take this mate away. Right now it's mated, stuck to that table. Got it? To that plane. If I want to constrain it dead center, I can. I can go into constraints. I can pick my center axis and my center axis and lock it into the center. Guess what happens when I do that? Anyone want to guess? I locked it to the center. Anyone in machine design or jig and fixture design or fluid power? What's going to happen? What do you think is going to happen? I can do what? Rotate it. I can spin this puppy around. Whee! See that? Cool. Isn't that awesome? That is step one of automation, is make sure that when you bring your parts into assembly, you constrain them in relationship to how they move. All right? If I lock this puppy down totally, as in I constrain one of these planes to one of these planes, guess what? I'm stuck, I can't move. Got it? So I only constrained it to the center so I can actually rotate this thing. All right, cool. Now in building, I might not want things to be so wiggly waggly, so I might lock it down, but I have to mentally remember I did that. All right, so if I do it right now, I'm going to go to constrain again, pick this plane, okay, cook, I locked it in. Now if I don't like the way I locked it in, I could switch that and say, no, I want to lock it in on that side. Why? Because that's where I want to draw the star. Random decision. Get it? Okay, I just chose a way to want to lock it down. I could just as easily lock it down on the other side or lock it down at 45 degrees. I don't care. Cool? And if you're going to ask me, what do you mean 45 degrees? I could lock it down by angle. And like I say, I wanted to lock it down at 45 degrees. See? Boop. Rotates over. Got it? Okay? You can decide how to lock it down. I'm going to lock it down straight. Whoop, I got to pick the side. When you want to pick a plane, you got to pick the edge of the plane. It gets really confused if it sees other stuff. So your goal is to find where you can just pick the plane you want to activate and find where you want to, here we go. Whoops, I want to activate it to that plane. But do I want it that way or that way? I'm choosing that way. Random choice, by the way, not a required choice. There you go. So now I'm in assembly. What's different in assembly is you've got still the model stat, relationship. Relationships are different. Okay, relationships are different. That tells me all the different mates I have in my drawing. Representations, different views. Origin is the same as if it was a part file, and then voila, this is a base. It's all about the base, remember that. Just joking. For you musical people, you know what I'm talking about. So there you got the base. Model stats. Whoops, let me pick that. Master and whatnot. And then origin, meaning where is it located, the usual. And then you've got your mates. So your mates will appear to their part, and all the mates will appear, up here in relationships. All the mates pile in here. Okay, and the mates specific to a particular part appear with their part. Got it, guys? Please remember that. Then I'm going to go and start the next part. So this is new, so I'm going to create a part. Okay, and I'm going to call this part the gear. I don't know. I'll just call that a gear. It wants to drop it in the same spot that my file exists, so make sure you have a place for it to go. So it has a good place, a good home to go to. I'm going to hit OK, and then it's going to ask me, where do you want to create it? I'm going to pick this face. Okay. Now here's where the fun begins. Why am I wanting to show it to you this way? I'm going to go create a sketch. I'm going to start a sketch. I'm going to pick that face to start my sketch. And I've taught you project geometry already within a part file. Now I'm going to teach it to you within an assembly. That's why I did this. Whole purpose of doing this. I'm going to actually project geometry from my other part. Okay, very important. I'm doing that so that you understand you can build one part from another part. That's the important part of this learning experience right here. You'll get a hot and cold symbol. To me, because I came out of the HVAC industry, I see HVAC symbols. Red arrow, blue arrow, yin-yang style, right? Right out of the HVAC system. What it really means here is that they're hot linked together. Got it? When one diameter changes, guess what's going to happen here? The diameter in this part's going to change. That's what this means. Now I can draw the rest of it. Let's see, what is the rest of it? I want the basic shape, right? So I'm going to go somewhere out here and just draw, whoops, draw a circle, excuse me. I'm going to reference off of there and draw this circle. So what is this? Is this locked in correctly? Whee! No, it's not. What should I do? I could draw a line from here to this object, make this a construction line, and then apply a horizontal constraint. Got it? Now, dimensionally speaking, what am I looking at? When I look at this line, where does this object align with this object? No clue. Or do we have a clue? Are they the same diameters? Are they different diameters? What do we know? What don't we know? Any suggestions? Yeah, the dimensions are right there. A radius of 38 is the outer dimension, right? So we could just, that's the easy part. We can assign that. Uh-oh, what happened? I'm in my assembly and I started a new part, but what units of measurement did it start it in? Dun, 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 dun. Inches, do you see that? How do I overcome this potential problem? 38 millimeters. No. Was that correct? Is 38 millimeters correct? It is, except for the fact that it's 38 millimeters times what? 2. See that? But it's giving me the dimensions in inches. You notice that? Okay. Remember I told you units of measurement. So where do I fix that? Tools, document settings. What units do I want to represent everything in? I want to say millimeters. Do I want the mass in pounds or kilograms? Kilograms, got it? Be mindful of these oddities. You can still move along, no problem. Get it? But I need you to be aware of these issues. Now, the next question might come to your mind, how do you know this piece of information? We want the center. There it is. That's where they want the Geneva Gear center to be. And their relationship to each other. You notice that? So where do I go for that? I go into Sketch, and I put in a dimension. So the dimension from here to here is, now it's giving it 2 millimeters, it's 18. See that? So that way I know what relationship I want the one object from the other object. Now I can actually complete my cut. See that? Because everything now is positioned correctly. When I do an extrusion this way, I'm going to do this intentionally like this so I can show you what it's going to do. Do I want to do it this way? Do I want to extrude this cut in this shape? By just one cut and then try to pattern it? No, I would not. What should I do? Should I try to pattern it in here? Or should I draw the basic shape and put in the cut as a secondary feature, blah, blah? What do you think? Any thoughts, any opinions? 6 of one, half a dozen of another is my answer to you. 6, literally, it doesn't matter. 6 of one, half a dozen of another. I'm saying the same thing. Doesn't matter. Half a dozen is the same as saying 6. So that's why I'm not going to worry about it. But what should I worry about? The location of that particular line. Where should it be? Dead on there. But does it go there? No. So what can I do? I can click on this. I can go to what? Well, it's already coincident. That's not the issue. What do we want it to do? This guy locked in correctly a tangent. Oh, tangent. There you go. Yep. Were you sitting there screaming tangent at me? In your mind? Yes. Good. I'm glad you were. Daniel, I could see you were screaming it. There you go. Got it. Now it's tangent. Now I can actually do something called what? I haven't used this with you guys in here, but you may have used it in other software products. I have to maximize this real quick to do this. Thank you. Just so I could see everything. Circular pattern. Inside a sketch, circular pattern. I'm going to pick the objects. But it won't let me pick the, darn it. So what should I do? What do I do with this object? Nothing. Just draw right over it. Got it? Don't have a heart attack over it. No, it doesn't let you. That's okay. Why won't it let me? What is so special about that object? It is the hot link to the other object. So when I trim that, and that's just sits there. Okay? Now let's try it. Circular pattern. There you go. See? Lets me pick everything. Cool? Cool? Yeah. Okay. Let's see. That's the objects. Okay. So I pick the geometry. Now I'm going to pick the center. Whee! Now how many? How many? A 1, a 2, a 3, a 4. 4. Whoops. 4. Why does it keep changing it to 6? 4. Oh, because I don't have my number locks on. Hello. Now I type in 4. Cool. There you go. And I hit OK. Yeah, I could trim those in, and I will, the trim back part. But I also have those little curves. Where are the curves? Should I have done those at the same time? Yeah, I should have, right? Which is these guys. These little curves. See those radius 27s? You see those? Now, how do I find where those go? Let me trim these back real quick. Like I told you, there's more than one way to build this thing, so I'm just showing you a way, not the way. What would I do if I wanted to build it as part of this and not separately? I would attach to this. I would turn this into a construction line. I would draw a circle. Should I have stopped that line all the way over there, or should I have gone further? Anybody want to give me their 10.5 cents on this? Inflation is why I say 10.5 cents, you know. It's no longer a penny for your thoughts. So I'm going to go from here to here. This I'm going to set to 45 degrees. I'm going to draw a circle out here. I'm going to go this way. What's the radius of that circle? 27. So it's 27 times 2 because it's a diameter out here. Whoops, that's far away. So where does it belong? A radius of 27 through its center, but where is that center? Anyone want to guess? This location is directly correlated to its partner, which is this guy. This guy. But we built it like this. Darn it. So what can we do? We can extrude this. A few things we could have, should have, whatever. We can talk about it till we're blue in the face. What did I make the other one? 3? What is it? 3 millimeters? What, 2 millimeters? 2. Okay. So I'll make this one 2. So now we have 2 parts. And the last part is actually a product of the 2 facing each other a specific way. We literally have to rotate these 2. Okay, so if I get out of my part file, remember this used to rotate, or did I lock it in place? What did I do? Do I remember what I did? I made it flush, let's see. Remember how I initially showed you this part rotates? So this was flush, That's flush. It was that one. I got to remove this so that way I could rotate. Whee! See that? Is that not gorgeous? It rotates the wrong way, but it's gorgeous. This guy is stuck to it. Notice that? Is that really what I wanted? No. Why? Which piece is supposed to be spinning which piece? This piece is supposed to be spinning this piece. Okay? So I'm going to stop the lecture at this point, but the one thing I'm going to show you, and you guys can figure, maybe you can figure this out for next class, that's on your own, that's up to you. But the first answer to fixing this problem is to turn off the adaptive feature. The adaptive feature is literally the hot-cold symbol. That's the adaptive feature. Once you turn that off, then this will move freely on its own, and this will just move on its own as well. Okay, that's step one to the solution. The next part I'll show you next class, and this will end this lecture for today.